Hey everybody, this is Larry, this is me going Q2 of the weekly contest 448, fill a special grid. Hit the like button, subscribe button, join me in Discord, let me know what you think about this one. The key thing about this one is, well, part one is probably reading, just reading it correctly, but you read it correctly, it's going to be 1, 2, 3, 4 in this order. I'll draw it out with ASCII art, right? You're going to be, and this is one index the way I have it, but if you divide it by 4 quadrant, you're going to have 1 on the upper right, 2 on the lower left, or sorry, lower right, and then 3 on the lower left, and 4 on the upper right? And then, so this defines one quote-unquote special grid, and then now recursively, each grid will be a special grid, so you can't go into it in that order, and that's basically how I did it. And in fact, you can even memorize it so that over 10 it'll be a little bit faster, but I don't think it matters that much. But yeah, and here when I just come with n to call my recursive memorized function, remember that if you try to memorize it, be a little bit careful because you do not want to save memory addresses or references, because then you maybe reuse them in an incorrect way, so be a little bit careful. But otherwise here, so we recursively for length for a grid of size x, or 2 to the x if you will, we go one smaller by looking at the special grid on the quadrants, and keep in mind that if you have an x by x grid or n by n grid, it's going to be n over 2 by n over 2 grid for one of the quadrants. It's in the name, it's a quad, right? Quadrant. So yeah, so you find it recursively, and then now, actually I don't think I even use L, I guess I use L here, to calculate the current grid size, and then L2 is just half of that for one of the size. And then yeah, you can see that I do upper right, and then I kind of copy the numbers over, right? And then I do lower right, I copy the numbers over, but also with an offset. You can actually do this with you could do this all at the same time, but I just like to write them out because it's a little bit more clear. And the offsets, we can you could see also, the offset is basically because when you're doing lower left, you have to do it after upper right, so then you do them in order by, well, calculating the offset of all the previous numbers, and that's it. Yeah, and then you repeat for lower left and upper right, and this is basically the function is recursive. And the base case, of course, if it has one element, and that is it. What's the complexity here, right? Well, believe it or not, this is, well, for well, I was gonna say linear, but it's not quite right in that linear is not the input, right? But for length 10, for n is equal to 10 as the input, you have you want the output to be 2 to the 10 times 2 to the 10, which is 1,000,000. For that, you only do O of 1,000,000 grid. So like for a given input n, you're going to do 2 to the n square, or 2 to the 2n number of work. And the reason is the same as kind of like binary search, right? In a sense that if you kind of just think about the recurrence, it is going to be, well, maybe not binary search, but maybe I'm wrong actually. But you even use the Master's algorithm here, right? Master's theorem, where O of n is equal to 4 times O of 4 times n, or sorry, n over 4, right? And that's it, right? Plus, I guess, O of n, right? And as a result, this is, like I said, it's going to be very similar to binary search. So this is just should be n log n. Maybe I'm wrong on this one, but yeah, but Master's theorem, right? So yeah, and that's it. That's all I have for this one. Oh, let me write it out, right? Because there's going to be log base 4 of these O of n steps. So this is going to be n log n base 4, say. And that's it. That's all I have for this one. I'm going to highlight the code. You don't even need to cache it, but I do cache it. But yeah, let me know what you think. Thanks for watching. And yeah, you could watch me solve it during the contest next. All right, let's go. Wasn't sure. I'm spending like an extra couple of seconds just so that I don't waste 5 minutes penalty. But I don't do it always correctly, so we'll see. Anyway, all right. 2n. Ooh, what is n? N could be 10, so that means 1,000 by 1,000 grid. All right. Grid is special. We satisfy all numbers on the low. All numbers on the upper or top right are smaller than the numbers on the bottom right. Right, I'm going to draw this out. All right. Oh, and it's recursive. Okay, so so top right, it's going to be the smallest. Bottom right is the second smallest. Bottom left is the third smallest, and then top right. Okay, so 1, 2, 3, 4. Okay. Yeah. Okay. So there's gonna be a million. I kind of want to do this. Yeah, I kind of want to do this recursively, but maybe it's fine. Yeah, I mean, I think you're supposed to do it recursively anyway. But okay, fine. Right, so here. Okay, so if x is 0 to 1, is it 1 or 0? If 0, then it's 2 to the 1. Okay, fine. If it's 0, then we just return. Okay. Okay, and then otherwise, we do the 4 quadrants, right? So, okay, and then otherwise, g is, you go say g of x minus 1, g for grid. And there are, so if x is 1, if x is 1, then there's 2 by side, so it's four elements, 2 by 2. So it is going to be, so each one of these is going to be 2 to the, okay, so 2 to the x minus 1 size for each of these, right? So that gives us the offset. Okay, and then r is equal to, let's say none times I wrote this a little bit awkwardly. L is equal to, right, and then smaller l. Okay, right. So then now we have L for right, and then we return R, say. So then now we want, okay, right. So then upper right is going to be okay, for I in range of smaller l, for j in range of smaller l, we want to say g or r of the, so I plus j plus smaller l is equal to g of I. No, this isn't right. It's not smaller l. This is, no, I guess this, L is the length of one side. So smaller L, okay, yeah. Length of one side. I don't know why I wrote it this way. Just put L2, say. Versus, okay. G of ij, right? And then lower right. Guess we just do the same thing, really. But then now the offset is plus L2. Is this plus offset is going to be L2 times L2? Yeah, okay, fine. Okay, and then lower left, same thing. Offset is going to be this times 2, except for now it's going to be on the row, so okay. And then finally upper left. Yeah, is that right? Okay, I think that's right. This one is just whatever. Okay, right. And then return go and I think that's it. All right, let's take a quick look. 3021. Okay, 5th. 30. Okay, so it looks okay for that one. One more thing I would have is just like performance, so let's kind of run it real quick. And maybe it takes. Okay, I mean, let's give it a YOLO submit. Okay, good. That was a little bit slow, but I don't know. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, this explanation, everything in between. Stay good, stay healthy, do your mental health. I'll see y'all later and take care. Bye-bye.